This harmless-looking larva will descend into darkness and acquire at least 10 of the strangest biological traits ever documented in a vertebrate. In particular, one of the most unique sexual reproductive strategies ever documented on Earth. Let's start. In the open ocean near the surface, sunlight still reaches into the water. Here, light defines everything. It determines where food grows, how predators hunt, and how prey survive. Vision matters, color matters, movement matters. Most fish that live in this zone are built for speed and efficiency. Their bodies are streamlined to reduce drag. Their muscles are dense and powerful. Their senses are tuned to motion and contrast. Energy is spent quickly because food, while never guaranteed, is at least frequent enough to justify the expense. Predators chase, prey flee. This is a world shaped by pursuit. And drifting almost invisibly among plankton and microscopic life is something that appears completely unremarkable. A larval anglerfish. At this stage, there is nothing monstrous about it. It is small, symmetrical, soft-bodied. Its proportions are ordinary. Its movements are weak but functional. Its skin is partially transparent, a common trait among larvae that live near the surface where camouflage depends more on invisibility than armor. Its eyes are present and functional. They respond to light. They track motion. They do what eyes are supposed to do. There is no glowing lure, no oversized jaw, no inward-pointing teeth. Nothing about this animal suggests what it will become. And yet, within a single lifetime, this harmless larva will transform into an organism with one of the most bizarre bodies, behaviors, and reproductive strategies ever documented on Earth. To understand how that happens, we have to follow it downward. The anglerfish begins life near the surface for a simple reason. This is where survival is easiest. Food particles are abundant here. Tiny crustaceans, plankton, and organic debris drift constantly through the water. A larval fish does not need specialized anatomy to feed. It needs only to encounter enough calories to grow. At this stage, the anglerfish's body reflects those conditions. The jaws are small because prey is small. The teeth are undeveloped because prey does not struggle. The nervous system is simple because decision-making is minimal. The digestive system is active because food is frequent. It swims like a normal fish. It feeds like a normal fish. And crucially, it looks nothing like the adult anglerfish people recognize. This change is not gradual in the way many animals simply scale up as they grow. It is not a matter of becoming a larger version of the same thing. It is a complete biological rewrite. As the larva grows, ocean currents slowly carry it downward. Over time, it leaves the upper layers of the ocean behind. The water grows colder, light weakens, food becomes less predictable. This descent is not dramatic. It does not happen all at once. It unfolds over weeks and months, downward, away from light, away from color, away from predictability. At roughly 200 meters, sunlight begins to fade in a meaningful way. Reds disappear first, then oranges, then yellows. What remains is blue, gray, and shadow. Vision still works here, but it is compromised. Shapes blur. Contrast weakens. Movement becomes harder to interpret. By 1,000 meters, sunlight is gone completely. Not dim. Gone. This region of the ocean is not just dark, it is permanently, absolutely dark. This is weird deep. This is bizarre deep. This is scary deep. Here, temperatures hover just above freezing. Chemical reactions slow. Metabolism becomes expensive. Growth becomes cautious. Pressure increases to hundreds of times what organisms experience at the surface. Every square inch of tissue is compressed. Any structure filled with gas becomes a liability. Food is no longer a constant background presence. It arrives sporadically, often in the form of sinking debris or unlucky animals that wander too deep. Most animals cannot survive here. Their bodies are not designed for it. Their energy budgets collapse. Their sensory systems fail. Their strategies stop working. Anglerfish do not just survive this transition, they specialize in it. As the juvenile anglerfish descends further, its body begins changing in ways that would be disastrous in shallow water. Bones become lighter and less rigid. Dense skeletons require constant metabolic investment. In a world where calories are scarce, excess bone becomes a liability rather than an asset. Muscles weaken and shrink. Speed is no longer an advantage. There is nothing to chase, and chasing would burn more energy than it could ever recover. Energy conservation becomes the central rule. Every calorie spent must serve a purpose. Every unnecessary movement is a mistake. The body stops being built for movement. It starts being built for waiting. This shift is one of the most important transitions in the anglerfish's life. It marks the moment when survival stops depending on pursuit and starts depending on patience. If this descent into the deep ocean has held your attention so far, consider liking the video and subscribing. It helps support long-form, science-based storytelling like this, and it tells the algorithm there is still an audience for patient, curiosity-driven exploration. In the next stage of its transformation, the anglerfish will abandon the last assumptions of surface life. Speed will become irrelevant. Vision will become unreliable. Symmetry will lose its value. What replaces them will look extreme, even grotesque. But in the deep sea, elegance is no longer the goal. Survival is. As the anglerfish settles into permanent darkness, the pace of its transformation accelerates. This is no longer a matter of fine-tuning existing traits. Entire assumptions about what a fish should look like are abandoned. The most dramatic change begins at the head. It grows disproportionately large compared to the rest of the body. This is not accidental, and it is not inefficient. In the deep sea, the head is where almost everything important happens. The head houses the mouth. The mouth determines survival. The anglerfish's jaw structure begins to loosen. Ligaments stretch. Bones that were once tightly locked into place become flexible. The joints are no longer optimized for forceful biting or repetitive chewing. They are optimized for opening wide, very wide. The mouth expands far beyond what seems mechanically reasonable. At full extension, it can appear as though the head itself is little more than a hinge attached to a stomach. This is not a defect. It is a solution. In the deep sea, meals are rare. When food finally appears, it may be the only opportunity for weeks or even months. Missing that opportunity is not an inconvenience. It is potentially fatal. To support this strategy, the anglerfish's stomach undergoes its own transformation. The stomach walls become thin and elastic. Internal organs shift and compress. The digestive system becomes capable of tolerating extreme expansion without rupturing. This allows the anglerfish to swallow prey nearly its own size, and in some cases even larger. But this ability comes with strict limits. The anglerfish cannot chew. It cannot tear prey apart. It cannot afford prolonged struggle. This is where the teeth come in. They develop slowly, but when they do, they are unmistakable. Long, needle-thin, almost translucent. Unlike the teeth of many predators, anglerfish teeth are not designed to slice or crush. They are angled inward, like a series of barbs lining the mouth. Their purpose is simple: prevent escape. Once prey crosses the threshold of the mouth, any attempt to retreat only drives it deeper inside. The more it struggles, the more securely it becomes trapped. This design turns physics into an ally. The anglerfish does not need to overpower prey through strength. It only needs gravity, panic, and geometry to do the work. This fish does not chase prey. Chasing is expensive. Chasing fails in darkness. Instead, the anglerfish waits, motionless. Energy use drops to a minimum. Muscles remain relaxed. Metabolism slows. The fish becomes part of the background. This strategy is known as ambush predation, but in the deep sea, it is taken to an extreme. Waiting is not passive here, it is deliberate. Above the mouth, another transformation is underway. A modified spine begins to extend from the head. This is not a separate appendage, it is a repurposed part of the anglerfish's own anatomy. At the end of this spine, a fleshy bulb forms. This is the lure. Inside that bulb live colonies of bioluminescent bacteria. These bacteria emit light as a natural byproduct of their metabolism. In most environments, this would be meaningless. In total darkness, it becomes everything. The anglerfish does not produce this light itself. It cultivates it. Through precise control of blood flow and oxygen delivery, the fish regulates when the bacteria glow and when they remain dark. The light can be steady, pulsing, or intermittent, depending on the species. This is not random. Different lure shapes and glow patterns appear to mimic different types of prey. Some resemble small shrimp. Others look like worms or drifting organic particles. In a world without sunlight, light itself becomes bait. Small fish approach, drawn by curiosity or hunger. Crustaceans drift closer, responding to the only visual signal available. They see the glow. They do not see the mouth. When the anglerfish strikes, it is not fast in the way surface. Predators are fast. It does not need to be. The distance between lure and mouth is minimal. The opening of the jaws creates a sudden pressure change, pulling water and prey inward. In many cases, the prey has no time to react. Anglerfish routinely consume prey larger than themselves. This is not exaggeration. It has been observed repeatedly in collected specimens. Their jaws dislocate, their stomachs stretch, their bodies distort temporarily to accommodate the meal. But this strategy is dangerous. If prey is too large, it may block the mouth, preventing respiration. If it struggles violently, it can damage internal tissues. If digestion takes too long, the anglerfish may starve despite having food inside it. There is no margin for error. There is no backup plan. Missed meals are common. Opportunities are rare. When food appears, the anglerfish commits fully. This extreme feeding strategy defines much of the anglerfish's anatomy, but it also creates a new problem. Movement becomes even less necessary. Speed becomes irrelevant. What matters now is not how well the anglerfish can hunt, but how long it can endure. This leads to one of the strangest consequences of deep-sea life: sexual dimorphism taken to an extreme. And yet, as remarkable as its feeding strategy is, it is not the strangest thing about the anglerfish. That distinction belongs to how it reproduces. In the deep sea, finding food is difficult. Finding a mate is far worse. The ocean at these depths is vast, dark, and sparsely populated. Individuals may drift for years without encountering another member of their own species. For many deep-sea animals, reproduction is a matter of rare chance. For anglerfish, evolution does not leave this to chance. It eliminates uncertainty entirely. Male anglerfish are tiny. In some species, a fully grown female may outweigh a male by more than 60 times. The size difference is so extreme that, at first glance, males and females appear to be different species altogether. This is not an accident of development. It is a deliberate evolutionary trade. Male anglerfish are not built to hunt. Their digestive systems are underdeveloped. Their muscles are weak. Their bodies are light and fragile compared to the females they seek. Instead, their anatomy is dominated by sensory systems. The male's brain is disproportionately devoted to smell. Olfactory organs are enlarged far beyond what would be useful in shallow water. Vision, already unreliable in darkness, becomes secondary. In the deep sea, smell travels farther than sight. Female anglerfish release chemical signals into the water. These pheromones disperse slowly, forming faint trails that can extend across great distances. Male anglerfish are exquisitely sensitive to these signals. They can detect concentrations so low they would be meaningless to most other animals. Once a male detects a pheromone trail, his behavior changes completely. He stops feeding, he stops conserving energy. Finding the source becomes his only objective. This journey may take days or weeks. During that time, the male survives on stored energy alone. His body is not designed for long-term independence. It is designed for one moment. In the vast darkness of the deep ocean, that moment may never come. But when it does, the response is immediate. When a male finally encounters a female anglerfish, he bites her. This bite is not aggressive, it is final. The male clamps onto the female's skin, usually along her body or near her head. At this point, the two fish are still separate organisms, but separation will not last. Specialized enzymes begin breaking down tissue at the point of contact. The skin of the male fuses with the skin of the female. Over time, their blood vessels connect. Circulatory systems merge. Once this happens, the male no longer needs to feed. He receives nutrients directly from the female's bloodstream. As days pass, his body begins to change. Eyes degenerate because vision is no longer needed. Fins shrink and disappear because movement is no longer required. Internal organs atrophy because digestion and respiration are handled by the female. The male does not die. He is absorbed. What remains is a living extension of the female's body, a permanent source of sperm. In some species, this process happens once. In others, it happens repeatedly. Some female anglerfish carry multiple fused males at the same time. Each one is genetically distinct. Each one is integrated into her circulatory system. This is not parasitism in the traditional sense. Parasites take without contributing. The fused male contributes continuously. This is sexual fusion, and it is almost unheard of among vertebrates. Under normal circumstances, tissue from another individual would trigger a violent immune response. The body would recognize the foreign cells as a threat and destroy them. Anglerfish do not do this. Their immune systems have been fundamentally altered. Entire pathways involved in tissue rejection are suppressed or missing. Genes that normally distinguish self from non-self behave differently here. This allows genetically foreign tissue to exist permanently without inflammation or rejection. The cost of this adaptation is significant. Anglerfish immune systems are less flexible than those of shallow water fish. They trade immune robustness for reproductive certainty. Once again, scarcity drives the decision. In an environment where encounters are rare, failing to reproduce even once may mean extinction. Certainty becomes more valuable than resilience. From an evolutionary perspective, the male anglerfish is no longer an individual in the traditional sense. He is a biological strategy. His autonomy ends the moment he succeeds. This raises a question. Why did evolution choose this path instead of others? Why not temporary attachment? Why not synchronized spawning? Why not seasonal migration? The answer lies in the deep sea itself. There are no seasons here, no landmarks, no reliable meeting points. Individuals drift alone through darkness, guided only by faint chemical signals. In such an environment, letting go is a risk evolution refuses to take. The male anglerfish does not search for multiple mates. He does not compete. He does not return to independence. He commits completely because partial commitment fails too often. This system ensures that when a female is ready to reproduce, sperm is always available. It is brutal, it is efficient, and it works. But this solution comes at a cost that extends beyond reproduction. It reshapes the entire biology of the species, and it leads to the final question. What does all of this mean? What kind of evolutionary pressure produces an animal willing to sacrifice movement, symmetry, immunity, and individuality itself? To answer that, we have to step back and look at the anglerfish as a whole. The anglerfish is not defined by any single strange trait, not the lure, not the teeth, not even the fusion of bodies. What makes it truly extreme is that all of these traits exist together as parts of a single system shaped by one overriding pressure: scarcity. In most environments, evolution favors balance. Speed is traded against strength. Vision is traded against smell. Reproduction is traded against longevity. In the deep sea, balance collapses. There is too little food, too much darkness, too much empty space between individuals. Under these conditions, partial solutions fail. The anglerfish survives not because it is specialized in one way, but because it is specialized in every way at once. This becomes especially clear when we look at the immune system. In most vertebrates, the immune system is relentless. It constantly patrols the body, identifying and destroying anything that does not belong. This is essential in environments where injury, infection, and parasites are common. But for anglerfish, this same system would make reproduction impossible. The moment a male fused to a female, his tissues would be recognized as foreign and attacked. The fusion would fail, reproduction would fail. So evolution made a choice. In anglerfish, key components of immune recognition are suppressed or altered. Pathways that normally distinguish self from non-self behave differently. In some species, entire immune mechanisms present in other vertebrates are reduced or missing. This allows genetically foreign tissue to exist permanently within the body without triggering rejection. The cost of this adaptation is real. Anglerfish are likely more vulnerable to certain infections. Their immune systems are less flexible. They cannot afford the same defensive redundancy as animals in richer environments. But again, scarcity dictates priorities. An immune system that protects an animal that never reproduces is evolutionarily worthless. Certainty beats resilience. This same logic applies to every other aspect of the anglerfish's biology. Speed is sacrificed because chasing prey fails too often. Symmetry is sacrificed because it offers no advantage in darkness. Vision is sacrificed because light does not exist. Independence is sacrificed because encounters are rare. Even individuality is negotiable. What emerges is not a collection of oddities, but a coherent strategy. The anglerfish is an ambush predator because movement is expensive. It uses light because light is the only signal that works. It eats dangerously large prey because smaller opportunities are too rare. It fuses permanently because temporary solutions fail in vast spaces. Each trait reinforces the others. Remove one and the system collapses. An anglerfish with fast muscles but no lure would starve. An anglerfish with a lure but no elastic stomach would waste rare meals. An anglerfish with sexual fusion but a normal immune system would reject its mate. This is why the anglerfish feels so alien. It is not halfway adapted, it is fully committed. From a human perspective, many of these traits trigger discomfort. Permanent attachment, loss of autonomy, bodies reshaped beyond recognition. But evolution does not optimize for comfort, it optimizes for persistence. And in the deepest parts of the ocean, persistence demands extremity. This is why anglerfish are so rarely seen alive. Their world is vast and they are sparse within it. What we know comes from brief encounters, submersible footage, and specimens brought to the surface after death. Even now, much of their behavior remains inferred rather than observed. There may be variations we have never seen, strategies we have not yet documented, limits we do not yet understand. That uncertainty is part of what makes them unsettling. They remind us that life on Earth is not defined by what is common or familiar. It is defined by what is possible. The anglerfish does not represent a mistake or an aberration. It represents what happens when life is pushed into a corner and forced to adapt without compromise. In that corner, elegance disappears, redundancy disappears. What remains is function. The larva that began life near the surface did not choose this path. It followed gradients of pressure, temperature, and food availability. It responded to physics, it responded to chemistry, and over generations, those responses accumulated. What began as a small, symmetrical, soft-bodied fish became something that challenges our expectations of anatomy, behavior, and even identity. Not because evolution sought to create something terrifying, but because this is what works. The anglerfish is not evil. It is not aggressive. It is not monstrous by intent. It is precise. It is evolution stripped of sentiment, and it offers a final, unsettling lesson. In the deepest parts of our planet, survival does not reward beauty. It does not reward balance. It rewards commitment, even when that commitment demands everything else. If you appreciate this kind of slow, scientific exploration, please like the video and subscribe to the channel. It tells the algorithm that there is still room for long-form curiosity, careful observation, and stories drawn directly from the natural world. And if this descent into the deep ocean unsettled you, there is far more waiting below.